Shoot. All right, so that first piece, Z was one we already did, 2.33. The sample mean I gave you, 64.17. N was 34. And sigma, where'd you go? 2.5. Because it's from the US, and that's how the heights are distributed. So now I just have to plug and chug. The mean, 64.17. Give or take this many. Thank you. What was it? Of those. All right. So if I start at my best guess and I go 2.33 steps out, I'll be 98% confident that I caught the real mean in there. Right? That's the whole idea here. This is how we go from what we see in a sample to what we want to say about a whole population. This is one of the first connections we're looking at. So your error came out a little weird. As some of you guys thankfully noticed, this is 2 decimal places. So you got to take this to 3 decimal places. 999. I know most humans would call that 1, right? But I'm a math teacher. I'm not totally human. So what do you get for the interval? 63.171 to
65.169.
So then we are 98% confident that the interval was 98% confident that the interval this to this contains the true mean height of women in this certain city. That's exactly what I'd want to see for your conclusion. How'd that go? Part A. All right, maybe. Okay. Part C says, okay, the first part, hopefully somebody tried to answer it before they did any work. If you want, this is a 98% confidence interval. If I want a 90% confidence interval, will it be wider or more narrow? More narrow, because I want to catch 8% less, right? So it's a trade-off. It's going to be more narrow, so it's going to seem like it's more precise, but the trade-off is a higher chance that I'm wrong. Okay, maybe. So the only thing that changes in all the work we did is this. That's for 98%. What is it for a 90%?
1.645.
Yeah, you can look at the old-fashioned way, 10%, 5%, 0.05, look it up. There's an asterisk. Or it should be in the little baby chart that I pointed out. A confidence level of 0.90, because it's another often used one. And so you do all the same work again, except you just plug 1.645 here. What do you get for the error then? Sorry, for the error?
Oh, 0.7053.
705? All right, cool. And so that error, already you can see it's smaller than that error. You're going to go out less, which again jives with the fact that we already knew it should have been not as wide. I don't have to catch as much stuff to be less certain. So then I get from who to what?
663, 464.
464?
Yeah, 464.
465? Up to
64 or 875.
875, yeah, good. So again, same exact wording. We are 90% confident that the interval this contains the true mean height of women in this city, in this certain city, wherever it is. Bless you. So an 80% confidence interval would be even smaller, right? So that's the thing about people think, well, these people are more certain. No, actually, they're not. How could I make this error smaller without changing my confidence? It's a weird question, but I'm not going to change it.
Use a bigger sample.
Use a bigger sample, yeah. If I make the sample larger, that's going to decrease my error. That's what we knew from day one. We knew that a larger sample is better. Well, here's finally the math going, oh yeah, you're right. Math catches up. If it's not already ahead of us. All right. I personally think that's plenty for today. So, Enjoy that. See you guys next time. We'll talk about part B next time.